We were talking about this during the break. This created a one-of-a-kind eclipse. The star is Betelgeuse, a red supergiant in the constellation Orion.
Hey there, space enthusiasts. Get ready to blast off into the cosmos with us. Welcome to Spaceverse, where the universe is our playground and curiosity knows no bounds. Join us on an interstellar adventure as we dive into the depths of space, uncovering its mysteries and marvels. From the secrets of black holes to the landscapes of alien worlds, we're here to ignite your imagination and expand your cosmic horizons. With mind-blowing visuals, expert insights, and the thrill of exploration, Spaceverse is here to get to the ultimate cosmic journey. So strap in, hit that subscribe button, and let's embark on an epic voyage together into the vast unknown of Spaceverse. In 1604, the universe witnessed the dramatic end of a star's lifetime as it exploded into a supernova. Now, centuries later, there is anticipation surrounding the potential for another giant star to go supernova. Betelgeuse, the red supergiant in the constellation of Orion, has captivated scientists and astronomers for generations. As one of the brightest stars, it is gradually nearing the end of its life cycle, having depleted its primary nuclear fuels. The significance of this dying star to the scientific community lies in its long-standing allure. For centuries, it has intrigued astrophysicists and astronomers alike, prompting questions about what makes it so unique. Betelgeuse, approximately 10 million years old, shines prominently with its orange red hue in the Orion constellation. Positioned at Orion's right shoulder, or left as viewed from Earth, it is a semi-regular variable star. On a clear night, one might glimpse it in the sky. With a radius about 640 times that of our Sun, replacing our Sun with Betelgeuse would extend beyond the asteroid belt, encompassing the orbits of Mercury, Venus, Earth, and Mars, an indication of its immense size and vitality. Betelgeuse, one of the largest stars in the universe and significantly younger than our 5-billion-year-old Sun, dwarfs it with a mass 15 times greater and a size 700 times larger, rendering it 7,500 to 14,000 times brighter than the Sun. Despite its variable brightness, Betelgeuse remains visible to the naked eye even at its dimmest phases. Its luminosity fluctuates in cycles, with periods lasting approximately 420 days, as well as durations of 185 days, 230 days, and even 2,200 days. Moreover, Betelgeuse experiences abrupt luminous changes that defy its known patterns. Located approximately 725 light-years away, the light we observe from Betelgeuse today began its journey over 700 years ago. This revelation often astonishes observers contemplating the star in the night sky. Unlike stars that maintain a steady radiance, Betelgeuse's dynamic variability has fascinated astronomers and astrophysicists throughout history, including figures such as the 14th-century astronomer Dimi, the 19th-century astronomer Angelo Secchi, and ancient Chinese astronomers. Observations of Betelgeuse have long held a place of great intrigue and mythological significance. The indigenous people of the Great Victoria Desert in South Australia wove Betelgeuse into their oral traditions. In South African mythology, Betelgeuse took on the guise of a lion casting a predatory gaze toward the three zebras symbolized by Orion's belt. Across the Americas, Betelgeuse represented a severed limb of a heroic figure whose leg was severed by his wife. The fluctuating brightness of Betelgeuse was associated with this severed limb, while the Lakota people of North America viewed it as a chief whose arm had been amputated. Known in Sanskrit as Ardra, named after the lunar mansion in Hindu astrology, Betelgeuse was also linked to the Vedic god of storms, Rudra, by 19th-century star enthusiast Richard Henley Allen. Betelgeuse's luminosity played a central role in countless mythologies, transitioning from a brilliant yellow hue, indicating its intense luminosity, to its present reddish color. This colossal star has witnessed the evolution of civilizations. However, significant changes began unfolding for Betelgeuse in the autumn of 2019. A visible disturbance sparked speculation that it might be approaching the supernova stage, facing complete extinction. In 2019, there was a notable decline in Betelgeuse's brightness, diverging from its typical cycles of brightening and dimming. Within months, the star dimmed by approximately 60%, an event now recognized as the Great Dimming. This swift and dramatic occurrence deeply intrigued the scientific community, leading many to speculate that Betelgeuse might be on the verge of entering its pre-supernova phase. Among the various theories proposed, one suggested that a large, cool, dark star spot covered a significant area of Betelgeuse's visible surface. However, Andrea Dupree, Associate Director at the Center for Astrophysics, Harvard and Smithsonian, led Hubble Space Telescope observations that indicated a dust cloud enveloping part of the star. Beginning their observations in early 2019, Dupree's team scrutinized the layers above Betelgeuse's surface. Hubble captured a surface temperature soaring above 20,000 degrees Fahrenheit. Between September and November 2019, researchers detected lines of singly ionized magnesium traveling at about 200,000 miles per hour, moving from Betelgeuse's surface into its outer atmosphere. This hot, dense material extended far beyond Betelgeuse's visible surface, cooling over millions of miles to form dust. According to estimates, Betelgeuse shed roughly twice the usual amount of material from its southern hemisphere during the 3-month outburst. Like all stars, Betelgeuse constantly loses mass, but at a rate 30 million times higher than the Sun. The outburst's likely cause was attributed to a convective plume erupting from deep within the star. These disturbances generated shocks and pulsations that ejected a portion of the photosphere, leaving behind a large, cooler surface area beneath the dust cloud formed by the ejected material. This fractured segment of the photosphere dispersed into space, cooling the created dust cloud that obstructed Betelgeuse's light from reaching Earth. The star's dimming throughout 2019 was starkly visible, even observable from backyard telescopes. However, after this dramatic event, Betelgeuse's condition improved in 2020. By mid-February 2020, it had dimmed by more than 2/3 of its usual brilliance, but by April, it had returned to its typical brightness. As of early 2024, recent observations suggest that Betelgeuse, the colossal star, is rotating at a much faster rate than expected. Despite having a diameter nearly 1,000 times larger than the Sun, Betelgeuse spins at a speed of 5 km per second, approximately 8 times faster than a jet fighter. Observations from the Atacama Large Millimeter or Submillimeter Ray indicated that half of Betelgeuse's surface appears to approach Earth, while the other half recedes. However, astronomers from the Max Planck Institute for Astrophysics propose that Betelgeuse's perceived rotation may actually be an illusion caused by its turbulent surface, marked by violent boiling bubbles. These bubbles, some as large as Earth's orbit around the Sun, create an optical effect that exaggerates the star's apparent rotation, particularly given its vast distance of over 700 light-years from Earth. In summary, Betelgeuse, being a relatively young and immensely massive star, rotates and emits mass and heat at an accelerated rate. Consequently, it will consume its fuel more rapidly, resulting in a shorter lifespan compared to other giant stars like our Sun. Based on current estimates, Betelgeuse is projected to culminate its evolution with a spectacular supernova explosion, likely within the next 100,000 years. When this event occurs, Betelgeuse is anticipated to shine as brightly as a half-moon for over 3 months. The supernova explosion will lead to the formation of either a neutron star or a black hole, emitting various types of radiation. Despite these cosmic fireworks, life on Earth will remain unaffected, aside from the enhanced brightness observable in the night sky. And that's it. Feel free to share your thoughts in the comments below, and stay tuned by subscribing for the latest updates in space exploration. Don't forget to hit the bell icon to stay informed as we continue our journey of exploration together.